When the Internet was first developed, the intention was to have a network that would connect educational and government organizations on a very small scale. When news of this network began to seep out into the general population, people wanted to be able to take part. As a matter of fact, it wasn't long until the boom of the 90s hit, and now millions and millions of people all over the world are connected to the Internet. Because of this limited size scope in the early stages of its design, the core protocol suite, known as TCP/IP, does not have any inherent security in the actual design. What I mean by this is your data is actually sent across the network in most situations as clear text. When this clear text is sent across the network, anyone can use a monitoring tool and actually read this information that's being sent. This is a huge security problem. There are a number of solutions to this, including now IPsec and SSL and TLS. IPsec gives us the ability to have that encryption we need for secure communications, not only across the Internet, but in our private networks as well. The big problem with TCP/IP then is that IP packets have no inherent security. Particularly, there is no way to verify that the claimed sender is the true sender. This is something known as non-repudiation. In other words, we can send data on our network in such a way that the sender cannot deny they were the original sender of that information. The second problem is the data hasn't been modified in transit, and we need to be able to verify that. So there's no way to determine if someone has actually accessed the data, changed it, and then forwarded that information on, which could be critical in many scenarios. And the third thing we cannot verify is that the data has not been viewed by a third party. In other words, it is possible that someone could have actually seen this information. All IP and TCP and other such protocols really do is make sure the data gets where it's supposed to go. And that's it. Because of that, it's very possible that some of these problems could exist in our environment. That data is being intercepted and we're not even aware of this. IPsec provides an automated solution to all three of these. First of all, authentication. The claimed sender is the true sender. Integrity. The data hasn't been modified in transit. And confidentiality. The data hasn't been viewed by a third party. IPsec gives us all of this in one automated solution with the ability to massively distribute this in our environment through Active Directory. To understand how IPsec actually works, it's important to understand the structure of a standard IP packet. A standard IP packet, first of all, has the actual data in it that we want to send on the network. In addition to this data, we have the actual TCP header. This is the thing that encapsulates the data or wraps itself around the data. And TCP determines the destination application on the machine we're sending the information to. The final part is the IP header. The IP header encapsulates or wraps itself around the TCP header, which in turn had wrapped itself around the data. So you can look at this as a layered structure. And the IP header is all about determining where the data should go on the physical network. So the IP header takes care of getting the data from point A to point B. Once it reaches point B, the IP header is removed. And now the TCP header says where the data should go within the point B system. And finally, once it gets to that location, the TCP header is removed, the data is reassembled and delivered to the application on the receiving end. Now, the difference between standard IP and IPsec is this. First of all, IPsec does start out with the data wrapped in a TCP header. Then, however, things change a little bit. Instead of going directly to the IP header, we interject an IPsec header between TCP and IP. So what happens is this is going to work in a fashion that we don't have to do anything to our applications to be able to use IPsec. Why is that? Well, our data is passed on from the application to the networking subsystem in the computer. And that networking subsystem takes care of wrapping it in TCP and then in IPsec, and finally IP to get to the destination. Because of this, IPsec is application independent, and that's one of the great beauties of using IPsec for confidentiality, integrity, and authentication in our networks. Now we can also use IPsec in tunnel mode. When we use it in tunnel mode, we have the data, the TCP header, and the IP header. But then we also have an IPsec header after the IP header in the end. So it's a little different than when we're using it in a protected packet mode within an internal network. In IPsec tunnel mode, what we're talking about is using IPsec with virtual private networking. And in this case, we then have another IP header on the end. Now, to understand how this works, the sending application passes the data to the network subsystem of the computer. The network subsystem wraps that data in a TCP header, which says what application it's destined for on the other end, or the receiving end. And then an IP header is placed around it as well. The next thing we do is we wrap an IPsec header around that, which could include encryption, or it could just include authentication and integrity. But we put this around it, and then finally another IP header wraps around all of this packet. Then on the receiving end, like an onion skin, we just pull off each one of these layers one at a time to get it to the destination computer, and finally to the actual application on the receiving end. So this is how the IPsec architecture functions for our Windows Server 2003 implementation.